everyone. Thanks for rejoining us. Geoff is asking David another question.
I'm curious about the weaning phase. I think that most of the ARDS research has focused on the very beginning, the first phase of the treatment of a patient and protecting the lung injury. But the more I've been looking at this problem, the more I'm convinced, and in fact, probably most of the lung injury that we are seeing is actually during the weaning phase, when you start getting spontaneous breathing interacting badly with the patient's ventilation, the mechanical ventilation. So in the COVID patients who that you're seeing who take a long time to wean, and now that you recognise that the traditional approach wasn't working, are you seeing, at least anecdotally, improved outcomes from your patients? In other words, do you think that you actually harmed a lot of patients simply because you tried to get them off the ventilator far too soon and it brought about all sorts of havoc?
I think we have, yeah. I think from what I've observed and just watching the work of breathing, just your gestalt of what their work of breathing, we don't measure intrapulmonary intrapleural pressures, of course. But yeah, I think that we may have actually harmed some patients by moving forward too quickly. And I think then that should make us reflect on what we think we have learned over the last 20, 25 years about the optimal approach to weaning patients from mechanical ventilation. If you do a trial of 1,000 patients where you do daily spontaneous breathing trials and you extubate the patients who pass, the majority are going to do well, but the majority of those patients are not going to be ARDS patients. They're going to be post-op heart patients and people with pneumonia and people with drug overdoses and drank too much alcohol or had too much sedation after surgery. So when you mix them all together, the abrupt weaning does prove to be statistically the right thing to do, but maybe there are a subgroup of patients like these who don't benefit from a more abrupt discontinuation. I don't know, just a hypothesis, I guess.
I've just got something to say to add to that. Probably 5 or 10 years ago, I had a medical student undertaking a simple audit in our ICU. And the bit that bothered me is that you come in to work to do your round and you'd find that the patient had been trialled on a whole lot of different interventions overnight. They go from one mode to the next mode, to spontaneous breathing, to this, that, the next thing. And in some patients, you might get half a dozen different changes in mode of ventilation within a couple of days. So I've always wondered whether or not a very simple audit of your quality of care is how many times does the ventilation get fiddled with, and multiple times, because if you're changing the ventilation and many times, means you're getting it wrong because you keep changing it. And that's probably an indication that this patient is not ready to be weaned and that you're trying to do a whole lot of things which the patient actually isn't going to get any benefit from. So looking at changes in modes and just examining the behaviours of people who are trying to wean patients might give some insights into whether we're getting it right or wrong in certain groups of patients.
I can just say something about modes, and I think maybe Ross would want to jump on too here. We talk about new modes, but if we look at the old modes, I think what's quite nice to hear here that we haven't discussed, which is a bad mode, in my opinion, SIMV. We don't discuss this anymore because now we're discussing either volume control PCV or something else. Yeah, at least one big cross we can put through. What do you think?
Yeah, I'd like to see the old SIMV removed.
Yeah, agreed.
I just think a controlled. Well, look, you can't just, if you've got someone who's paralysed and you've got them on SIMV, I don't have a problem with that. But in the main, SIMV, the moment the patient starts to exhibit some form of ventilator interaction, giving them an absolutely controlled inspiratory breath is completely bananas to me, and can only harm them, and can only make them more distressed, and it can only increase their work of breathing. So yeah, I think ESIMB is just there because of Luddites and people don't want to move forward.
Geoff, when you say controlled, are you talking about a volume breath?
Yeah,
Okay.
I'm talking about actually the controlled flow.
Yeah, because I really like controlled pressure, the old PCV or the
Yeah.
and in SIMV form. In fact, I listened to the first podcast we had, and you guys were describing a need, and unfortunately, I'm here operating the controls, so I'm not always clicked into the conversation. But in listening to it in hindsight, I said, "My goodness, they're asking for PCV with a volume limit." And that was kind of the discussion we had.
Hey, Ross, what do you think?
So I agree with Geoff. I mean, as you said, if you're using SIMV in a paralysed patient, then actually you're not using SIMV at all, are you? Because it's actually just to control mandatory ventilation, either pressure control or volume control. Once the patient starts to breathe, the SIMV becomes very complicated very quickly. Unfortunately, Australasians have a love affair with SIMV, which goes back many years, and I'm not sure why they persist with it, but many of the units in New Zealand and Australia still use SIMV as their go-to mode. I'm like Geoff, I think it should be not necessarily banned, but it doesn't add anything to the ventilation except complications, understanding complications. And I also agree with Geoff that probably auditing the number of modes that are used, mode changes that are used in a 24-hour period would give you an indication of how well people understood ventilation. I always describe it like driving a car is that, if I was to drive a car on a windy road and race Lewis Hamilton and you gave me a Ferrari and Lewis Hamilton a simple Toyota Corolla, he'd probably beat me because he's a better driver. And so I think with ventilation, it's not the mode so much as the driver. And I think the desperate trying to keep changing cars. I mean, I think it's a sign of not understanding the mode very well if you have to keep changing the mode to get to effect. Having said that, there are certainly some modes that are easier to use in spontaneous breathing patients than others. But the philosophy that seems to have been lost is that has changed as we now have a weaning mode as opposed to a controlled mandatory ventilation. And I thought for many years that was not the right way to go, but I think in very unwell patients, the idea that in the first few days, and it sounds in COVID like it should be for longer, we use a very controlling mode. And that philosophy in itself needs to be propagated, that the idea of early weaning is important, but weaning too early can be disastrous. And I think that's where you get the synchrony, which Geoff was talking about. I think we need to be careful that we avoid that. And of course, the way to avoid it is to stop the interaction by the patient. You can make the machine very clearly interact with the patient, or you could stop the interaction altogether. And that's perhaps the strategy we should be using. However, once we do wean the patient, we need to think about carefully which modes, which parameters we control to deal with those. And I think the flow using a pressure or volume, you either control the flow or control the pressure, is probably very important as far as the synchrony. If you control the flow and the flow is inadequate, you get a lot of inspiratory dysynchrony. And the end of expiration also get dysynchrony, which is important. So even talking about dysynchrony, we need to break it down into inspiratory and expiratory dysynchrony, or timing dysynchrony as well. And that these are all important concepts. It's quite complex. Rather than talk about dysynchrony as an overall concept, we should break it down to different parts.
Yeah, thanks, Ross. Just this is probably slightly off topic, but I think that where the research into ventilation needs to focus is in trying to understand a bit more about the human behaviours, that is the clinician ventilator behaviours, as much as it is about the patient ventilator behaviour. You've got three entities in this room. You've got the clinician, the ventilator, and the patient. Now they've got to interact in a meaningful and optimized way. And the example I use is changing the modes, and because you keep getting it wrong. But one of the things that we should as globally move towards, in my opinion, is to audit and have it, a cloud-based system whereby we have minimum data sets of metrics we believe are important, which are a measure of both how the clinician behaves and how the patient behaves. And only when we start to do that are we going to be able to look at patterns of what's important and what's not important. And coming out of that as well, I also feel that we need to have within each ventilator what I call the flight data recorder, the black box, that actually might, if you've got problems in memory, you can say just record, the last 2 hours of data sort of thing, and that if there is an event, then that is saved, and then that can be used to totally resimulate the event, so that in the light of day, because these things seem to always occur at 3 o'clock in the morning, with the most inexperienced registrar, who then gets into all sorts of trouble, and the patient aspirates, or something bad happens, you find that they've got the FiO2's gone up and they're back on all their inotropes again. And this is a large gap in our ability to manage our patients, because we just cannot learn about what's happening with our patients during the weaning phase if we are always blind as to what's going on. So I'm proposing that we, and I say we're all we, that the clinicians collectively work with ventilation companies, instead of trying to develop necessarily new modes, try to understand about the behaviours of the patient, the clinician, and the machine, and to give us greater insight into some of the mechanisms that are causing harm during, and I would argue, the weaning phase of patients. So there we are. That's a huge challenge. I would put it out there.
That's a good summary.
Yeah, it's an excellent summary. Graeme, you may be able to add to this, but there are, most ventilators that I've developed and launched do have that black box. We don't necessarily disclose it to you. In the US, we keep it quiet because of the highly litigious state that we exist in. We can go to the black box. The purpose of the black box was really to protect the ventilator manufacturer, and we're constantly checking the function of transducers and of the impedance between or energy being sent to the valves and a lot of things. And we do document in our ventilators the ventilator changes and those interactions. Then when you take it another step further, I know that hospital systems, at least in the US, do require in many cases for the ventilators to be connected to a larger data gathering centers. So we're on the cusp of having the kind of data we need. And clearly it will require physicians to review and interpret it and understand in the light of day. But again, I can say that in the Medtronic vents that I was involved in and in the event vents, we do have those black boxes. They're just not necessarily presented to the clinicians, and maybe that's something we need to reconsider. Graeme, what about the ventilators you've been involved in?
Well, you and I go back to PV together, right? So, we the 840, that's right. I think all new ventilators do have it. I mean, we have extensive training information. We have a lot of information being stored. Some of the ventilators can give for 1 year of data. Like you said, we can download as much what I call rubbish as you want. The ventilators have a lot of power to deliver. It's really what the user wants or needs. And I think it's okay for us as a group to have that conversation, but a lot of clinicians, the black box concept is too much, because what are we trying to do? Make the ventilator smarter, or just give you information? I think is an important point, but the ventilator store information.
I tell you what, I think the problem is we don't know what we don't know. We don't also know what we need to know. And at the moment, we don't have a way, it's catch-22, we don't actually have a way of figuring out what we should be doing. So I actually was unaware that you have all this very rich data stored within the ventilators. It would be very useful to start engaging with conversation with clinicians to say what sort of data might be useful that would inform your clinical practice better. If you need to start with small steps to work out what might work, and then we can start to see if there are particular, if you like, issues or concerns that keep coming up time and time again. It may well be that if there was a simple audit that you can run on your ventilators, that you could see that a whole lot of this type of ventilator synchrony or staff synchrony, I'm going to call it staff, I just made that up, where staff themselves are behaving in a desynchronous way. They're actually, one person comes along, tries them on this, someone tries them on that, and that's not going to work. That sort of behavior you could pick up quite easily in an audit, and you could correlate that at least with patient outcome. And it may well be that we are missing this large elephant in the room, and that by failing to address the way that we behave and the way that we run these ventilators is actually to miss an opportunity to, in fact, reduce the harm that we produce in our patients. That we're actually looking for solutions in the wrong places is what I'm trying to suggest.
You know, at one point we even had lockout features to lock out certain physicians built into the ventilator. And we decided that wasn't a good idea. It was certainly applauded. It was a selling feature to the therapists and the nurses, but the physicians and the need for speed basically had us withdraw that feature set. So based on starting in baby steps, then let me ask you guys this question. If you're looking at work of breathing, and I know that we previously described or conversed over the fact that you can't just put it into one big bucket, but I'm going to do that right now and focus maybe on weaning. As you're applying weaning and you're thinking of work of breathing, what are the 3 parameters each of you physicians would say you must have if you could only have 3 parameters on your ventilator screen? What are the 3 parameters you would want to look at and monitor? And maybe after we're done with this, we'll call this session quits and look forward to the next one. But I think that's a good, I would certainly be interested in hearing if it's a conjoint analysis technique. We're going to ask you to make some trade-offs and pick 3 things you can monitor. And they don't necessarily have to be in the ventilator. They could be something like blood gases or et cetera. But take a shot.
According to what you asked before, outcome, happiness, and probably some other parameter would be good. If we could measure those, Steve, then we'd be happy. But I think we'd probably want to know what the end inspiratory pressure is, so a measure of the plateau pressure. Whether that was on pressure control, obviously you want to know the volume. Without that, we've got no measurement of anything. What the other third parameter is, I don't know. Things like respiratory rate, we can measure from the outside the patient. The ventilator doesn't have to do that. But I would have thought that knowing what the pressure at end inspiration, the tidal volume, to give us some degree, a measure of the compliance is important.
Right.
I would also agree with Ross that respiratory rate is my first one, and if I can have the resource of esophageal pressure monitoring, I will go for that. And the third one is plateau pressure. And being facetious, I would also look towards artificial intelligence to build some sort of facial recognition to see whether the patient is happy or distressed. Because I think that's what clinicians do. You're looking at the patient's face a lot.
Not your own.
Not mine, not mine. Patient's faith.
Yeah, I would agree with that. I think the question you asked was in the weaning phase. So I would say the 3 parameters I would, ideally like to have would be the respiratory rate, the tidal volume, and the intrapleural pressure, or whatever surrogate of that would be available. Obviously, it's not currently, but that would help me.
Geoff here. I'd have to think about this one. I want some measurement of lung strain somewhere in there. The dynamic respiratory elastance can be calculated without the need to get plateau pressures and all those sorts of things. It's a regression equation that just uses equation of motion to work that one out, which is what one of our research streams is doing in my own work. So a reason for having respiratory elastance there is it does give you insight into what's going on with your patient. And if you had that in real time, you can see what happens when you recruit patients up, when you turn them from side to side. So that would be one parameter. I'm trying to think of parameters which are what I would call integrals of many other parameters that give you a single number. And I'm struggling. I like the happiness as a final integral. I'm trying to work out how you could measure that somehow. I would like to look at some other sort of metadata that looks at what clinicians are doing, so we understand it better. It may well be that clinicians, through their own intuition, which we can't even explain, and by good luck, happen to find optimal ways of ventilating patients, but we haven't got the intelligence to actually understand that. So I would like to see globally connected data, I would say minimal data sets that are available for all of us to look at, to actually see where we sit in our unit compared with that units around the world. And that would also provide some insights into whether we're on track or not on track.
Sounds great. Sounds like we have potentially started the information race in mechanical ventilation. So let's hope that happened. Gentlemen, I want to thank you again. Your time is so valuable, and you've shared it with us. So a great sense of gratitude we all have for the time that you've put into this. And we'll see you again next week. And I want to leave you with the same old breathe easy statement. Breathe easy, guys. Thanks.
Thank you very much. Bye-bye.
Thank you.